I'm Rosie Willatt. I'm a postdoc at UCL, and I'm going to talk about Ku and Ka band radar data gathered during MOSAiC. This shows the typical assumptions about where the main scattering horizon is located for Ku band radar altimeters such as Cryosat-2, Ka band radar altimeters such as Altica, and laser altimeters such as ISAT-2. And these assumptions have been used to derive snow depth products by looking at the difference in retrieved heights, for example by Isabel Lawrence and Ron Kwok. We know that the snow properties are likely to affect where that main scattering horizon is, and that these in turn are influenced by meteorological conditions, which makes MOSAiC the ideal opportunity for looking at how the snow characteristics and radar return echoes evolve through time as the seasons change. The instrument that was used is a Ka and Ku band instrument described in detail in Julien's paper in the Cryosphere. Just to draw your attention to the main characteristic, which is that the central frequencies were close to Cryosat-2 and Altica, but the frequency band was much wider, giving much better range resolution so that we were able to resolve the air, snow and snow ice interfaces. So the KUKA data were compared to MagnaProbe-derived snow depths, which are shown colour-coded on the colour scale here. And in order to compare the datasets, they were transformed from lat-long into flow grid coordinates using code by Stefan Hendricks. I broke down each one of these transects into 3 metre sections, and I took the average Ku band echo, average Ka band echo, and average MagnaProbe snow depth for each section. Looking at the MagnaProbe-derived snow depths, we can see that the northern transect, shown here in red on the left-hand side, shows generally larger snow depths with larger ranges as shown by the vertical lines, and the southern transect shows generally smaller snow depths. So now looking at the radar data, in the VV polarisation, so this is photons that are transmitted vertically polarised and also received vertically polarised, you can see that for the Ka and Ku bands, it appears that the air-snow interface is the main scattering horizon for most of the way along the transects, with the northern transect shown here on the left and the southern transect shown here on the right. Looking at the same transect, but looking at the HV data, so these are photons that were transmitted horizontally polarised and received vertically polarised, we can see that the main scattering horizon appears to sit below the air-snow interface. And this is quite exciting because it shows that there's some potential to detect, using these data, using a comparison between the two different polarisations, to detect the snow depth. So I wrote some very simple algorithms to try to pick the air, snow and snow ice interfaces out of these data, and these can be compared to the MagnaProbe-derived snow depth, which is shown here in white. And we can see there is some visual agreement. This is in the Ka band VV data, Ku band VV data, and then the Ka band HV data and Ku band HV data. And if we plot these against one another, we can see that there is some agreement. So the radar-derived snow depths are shown on the x-axis and the MagnaProbe on the y. The R values are not perfect, and we wouldn't expect them to be because the radar and MagnaProbe data are not gathered perfectly spatially coincidentally, and because we have not been able to perfectly scale the radar for the reduced velocity in snow, because we don't know the exact snow characteristics at every point at which KUKA data were gathered, so they've just been multiplied by 0.8, which is an average velocity for these kind of snow conditions. But we see a really encouraging agreement, and there are lots of avenues for future work on this around improving the algorithms that are used to detect the air, snow and the snow ice interface, and resampling the radar data to Cryosat and Altica bandwidth to see what could be done with data with the reduced range resolution. And that's something that I'm working on at the moment. Thank you for listening.